Mr. Ganye here. I'm here to present IGC Physics 0625, and we are going to look at the topic motion. This is a very common topic in our physics syllabus, so we go straight into it. We have selected a few objectives from the syllabus IGC SE 0625 physics syllabus, the topic motion. You are required to define key terms which we find under this topic, terms like motion, speed, velocity, acceleration, and deceleration. Calculate the average speed, acceleration, distance, following simple equations of motion. You are also going to be required to sketch, plot, and interpret distance time, speed time graphs, then describe the motion of an object from the speed time and the distance time graphs, a very common question in the exam. You are also required to calculate the speed, acceleration, distance from the speed time and the distance time graphs. We move on. Terms under motion. You are going to see that in our lesson we are going to have some tasks that you are going to do. Like the first task here is for you to define the key terms under motion. And as you define these key terms under motion, you classify them as scalars or vectors. Terms like distance, displacement, acceleration, deceleration. So you need to do that before moving on with the lesson. What is distance? What is displacement? What is acceleration? What is deceleration? And can I classify them as scalars or vectors? Another section in our physics syllabus. Equations of motion. There are a number of equations that you have to know and which you have to use in the exam. So we are going to run through all of these equations here, and we'll see which ones we'll use as we move on. The first equation that we are looking at here is average speed. You are required to calculate average speed, and for average speed we are saying is total distance covered or moved divided by the time taken. What are the units for average speed? The units for average speed depend on what you have used, meters per second or kilometers per hour. So you need to know which unit am I going to use. It depends with the question that you have. Sometimes you have to change from meters to use kilometers and the like. So make sure you match these, meters per second or kilometers per hour. The next formula that you need to take home is velocity. Velocity, we are going to use velocity equals distance moved in a stated direction divided by the time that is given or taken to do that. And if you look at this, distance moved in a stated direction is our displacement. So if you go back and you look at the definition for displacement, it is actually distance, but this distance is covered in a stated direction, which means here is displacement and it's a vector. So that idea of scalars and vectors comes in. So velocity is displacement divided by the time taken. It will have the same units as speed, meters per second or kilometers per hour. We move on. We have acceleration. We started by giving the definition for acceleration there, which is the change of velocity in unit time or per unit time. From this definition already, you should be able to come up with the calculation or the formula for calculating acceleration. In physics, you can use formulas to define a concept. Acceleration already here is coming in as change of velocity divided by the time taken for the change per unit time or unit time. We have the formula here. A for acceleration equals change of velocity over time taken. And we are now using these symbols which we need to talk about. V minus u over t. What is V there? V is your final speed or your final velocity. U is the initial, the starting speed. And T is the time taken, which can be mostly in seconds. You will see that when you get a question, these terms V, U, T are given there, but most of them they appear in words. So you have to be very observant. Like an object which is at rest, it means it's not moving, it means your U is 0 there. So already that's a very important word there, at rest or not moving. It means your initial speed is 0. Then we move on. The units of acceleration are meters per second squared. Meters per second squared. Right. We have these other formulas here which we can also use to calculate motion. Like the first one here, V equals to U plus AT. And we've already said that V is our final speed or our final velocity, which is equal to your initial velocity, initial speed, plus acceleration multiplied by time. So that's a very important formula that we need to remember, which we use to calculate final speed or final velocity. And interestingly now, once we have one formula like this one, it means we are able to calculate U, we are able to calculate A, we are able to calculate T. You can see the relationship between V is equal to U plus AT, and this one here, going back to acceleration here, acceleration A equals V minus U over T. We are just playing around with your subject or formula in mathematics. This one and this one, the same formulas, but the other one is the subject of the formula. We have this one, which is giving us the distance shown by the letter S. The letter S represents our distance here, small letter s. And we are saying it's equal to the average speed, which is U plus V divided by 2 multiplied by time. This is the original formula which we have been having from there, which says that distance equals average speed multiplied by time. It's the same formula. So S here is representing your distance. In some situations or in some questions, this S might represent your height, your depth, your length. All those are under one bracket. They are distances which you can use this formula. We have the second formula there again for calculating distance, which is U multiplied by T, UT, plus half AT squared. Your U, we have already discovered that this is your initial speed or initial velocity, multiplying your time, plus half multiplying your acceleration and your T squared, which is your time squared. Then you will get the distance, you will get the height covered, depth or length. So you can also use this formula. The final formula which we have here is for calculating final velocity or speed. It's equal to V squared minus U squared plus 2AS, which is shown here. And you can go on to make the subject of the formulas. You can also calculate U, you can also calculate A, you can calculate S. You can do that. So these are key formulas that you need to have, which you will be required to use. We move on now to the motion graphs. We are going to start by looking at a speed time graph, also called a velocity time graph. So in the exam there, the question is there, it's on motion and there's a graph. You need to first of all identify what type of graph am I using. Is it a speed or velocity time graph? You look at the axis here, the x-axis and the y-axis. And the y-axis, you will see, is it velocity, is it speed, and time. Because we also have a distance time graph. We have a distance time graph, so it should not confuse you. You can be required to draw this graph or to sketch it, as one of the objectives said there. So you can do that, a sketch or drawing it. Then the next question which usually comes is this one highlighted here, where you are required to describe the motion of the object which is here. You are required to describe the motion. And we are saying when you are required to describe the motion, you are supposed to describe to the examiner there what is happening to the speed, what is happening to the acceleration. Those are the two things which you need to explain or to describe there. The description now comes in when you use ordinary describing words which we have in your language there. Words like increasing speed, decreasing speed, constant speed, uniform speed, steady speed. Same thing again, we have increasing acceleration, decreasing acceleration, constant or uniform acceleration. So this question is very simple. You are supposed to describe speed or acceleration using words like increasing speed, decreasing, constant or uniform or steady. That is what we mean by motion. Then the next question that will come there is to do with the acceleration, identifying the acceleration on a speed time graph or velocity time graph. And we are saying the gradient of a speed time graph represents the acceleration. You'll be required to find the gradient. With your mathematics there, you'll be required to find the gradient. And what is this gradient now? The calculation for the gradient comes in here. Change in speed over change in time. Change in speed, if you follow, is on the y-axis, and change in time is on the x-axis. So it's linked with your mathematics there. Can't separate this. Acceleration is gradient, and how do we find gradient? Change in y over change in x, which is in this case change in our speed over change in time. So you need to know, let's say you are calculating the acceleration here. You are calculating the acceleration here. You need to know the initial here, speed or velocity, and the final here. Then you subtract these two. The final, subtract the initial. V minus u. Remember that other formula which we had there, V minus u. Over the change in time also, from this end to this end, the time there, change in time. It will give you your acceleration. Then, if a line is a constant gradient, it means its acceleration is constant. Like what we have described in here, this part. This is constant acceleration, constant gradient. If we calculate the gradient at each and every stage here, you are going to see that it is constant. It is not changing. So we describe this as constant gradient, constant acceleration. Then, a curved line represents a changing acceleration. A curved line represents a changing acceleration, and that changing acceleration can be either decreasing or increasing acceleration. We are going to look at this one on the last slide that we are going to look at, a curved line, which represents a changing acceleration. So, describing motion, we are saying you describe speed and acceleration using words like increasing, decreasing, constant, uniform, or steady. On a graph of speed time or velocity time, we have constant acceleration here. We have constant velocity or constant speed. The speed is not changing, it's remaining at the same level here. Then we have deceleration, constant deceleration, describing motion. We move on. On the speed time graph, the next question that will come is for you to calculate the distance covered by the moving object. You will be required to calculate the distance covered by the moving object. And we are saying the key thing there is to calculate this distance, you are saying area under the graph. Calculating distance, you use area under the graph. And in the exam, it's good to write this area under the graph. It is marked as a formula. So it's good to write area under the graph. You can get your 1 mark there or a point there. Don't leave it out. So the area under the graph depends with the type of graph that you are having. So at the end of the day, you can have a triangle as your shape under the graph, which means you are going to use the formulas for calculating the area of a triangle. From your mathematics, area of a triangle equals half base times the height. So you will use it here, because this first part of the graph here, the area under this section here is a triangle. This triangle shown here, which I'm highlighting here. So it's half base times height. The second part of the motion here is represented with a rectangle or a square, depending on the dimensions that we have here. But you see that the area is calculated the same way. Area equals width multiplied by length. So to get this distance, which we are saying this distance is equal to our area, you are going to calculate the area of this shape, which can be a rectangle or a square, depending on the motion of the that we are having here. So on a speed time graph, on a velocity time graph, calculating the distance, we use area under the graph. This can be a triangle, a rectangle, or a square. So it's good for in the paper there or in your exam to draw this division here. Then you know that I'm dealing with this triangle. You calculate it, you move on, you calculate this other shape, which can be rectangle or a square. We have a worked example here which we are going to go through together, showing the velocity time graph and the movement of this object. You are required to calculate the distance covered in the first 5 seconds there of this motion. And we are saying to find this distance, you need to get the area under the graph. And there are many ways of doing it. Here we've indicated one, where we have separated the motion here into two different shapes. We have the lower shape here, which is in the form of a rectangle, shown by O, P, R, S. That's a rectangle there. Then the other side here, we have a triangle, which is shown there. And you are going to use area of a triangle to calculate this part. So we are saying you need now to compute this in your calculator, and you follow your formulas. Area of a triangle, half base times height here. Then area of a rectangle, length times width. It should not be a problem there. Our length 20, our width 5. Multiply that 20 by 5 here, you get 100. Then you go to the triangle here, using half base times height. You are going to have your formula here, half, multiplying the 5, multiplying the 20. How are we getting the 20 there? That's another area which you need to look at. Our 20 here, you are starting at 20 here on the speed, going to 40. So 40 subtract 20, this gives us a 20 here. That is where the 20 is coming from. Very important to notice that. You are not going to use the full height or full length up to 40 there. You say 40, subtract the 20 here. Take note of that one. And to add all this, then you get your distance covered under this section is 150 meters. You can go through this at your own pace. Try to understand it, because you need to know this so that you can use it on the questions which are at the end of the lesson. Right, a key thing to note here, especially the extended option, is the aspect of the change in the units. You need to note that the units of time must be the same on both axes. Here we have meters per second. If you follow our graph here, meters per second, and this side we have seconds, so the units are the same, seconds, seconds. We work it as it is, like that. You are going to get some questions in your exams or your vision materials where these units are not the same. The other one here is maybe kilometers per hour. This side is even minutes, it's even seconds or hours, something different. So we are saying when that appears, when these units are different, you need to take note of that. I need to change my unit so that they are the same. A very important point here. Take note of that. We move on. We've got non-uniform motion, which is represented by a graph which is curved. If you go back into the lesson, there's somewhere we talked about a curved line, like the one which is shown here. We are still dealing with a speed time graph. Still dealing with a speed time graph. Still dealing with a speed time graph. And we are saying when it is curved like this, it means it is representing non-uniform motion, where either the speed was increasing, the acceleration was increasing at some point, and it's shown by a curved line. It's no longer a straight line like what we used to have on these other graphs here. If I can go back here, straight line, straight line. This is uniform motion, and most likely in a straight line, not changing. Then we are on this other one now, where we are saying we can have non-uniform motion. In this case, we are saying this graph, which is showing it going up, curving upwards here, like what is shown here, what I'm highlighting here, curving upwards, this is showing increasing acceleration. There's an increase in the acceleration of this object here. Because when we calculate the gradient here, we get a lower value. It's not very steep. Remember, gradient, the steepness of this line or this curve. If we calculate the gradient here, it's not very steep. It's a low gradient, low acceleration. Then from there going upwards, we see that the acceleration is increasing. There's an increase in the acceleration there. There's an increase in the gradient. So when we calculate the gradient at position 2 here, we are seeing that we are going to get a high value here, which means our acceleration is increased. So this motion, which is non-uniform, is shown with a curved line, and you'll be required to calculate the gradient, which is the acceleration. Then the question of concern is, how do you calculate this gradient? How do you calculate this acceleration? You are required to draw a tangent. This straight line from your mathematics, you've got a tangent, a line drawn onto a curve, touching the curve at one specific point. You draw a tangent. Here we also have a tangent drawn. And once you've drawn the tangent, you are going to calculate your gradient using the triangle method. Using the triangle method, you pick 2 points which are on the tangent, which you are going to use now to calculate your gradient. Your change in the speed, which is your change in y, over your change in x, which is your change in the time. So this will give you your gradient. What are the key things here? You need to draw a tangent touching the curve at one point. They can give you that point in the exam. You can have this tangent, you are told that T2 is at 10 seconds. So you go there, 10 seconds, where you touch this curve, you draw a tangent there. Then you calculate your gradient using the triangle method, change in y over change in x. So that's a typical question which comes especially in the extended option. Those are going to be writing extended option. You need to check this one down. So notice that the gradient of the graph becomes steeper. We've mentioned that it's increasing there, it's becoming higher and higher. It means the acceleration is increasing. The gradient of triangle 2 is larger than the gradient of triangle 1. We have commented on that. When you calculate your gradient here, it's going to be higher. It means the acceleration here is higher than the other one. The gradient is becoming more and more positive. It's increasing, as shown there. So this means that the speed is increasing with increasing acceleration or increasing rate of change of speed. At a time t1, the acceleration is a1, which is in this case lower or less. Then as we move on to t2, the acceleration is a2, which we are saying is higher than at a1. There is an increase in acceleration. Very important concept there, where you make use of the tangent to calculate your gradient or your acceleration by using the tangent. We move on. We also have another option there, non-uniform motion 2, which is shown by showing a decreasing acceleration. The object is decreasing its acceleration. which means the gradient is decreasing. Look at the gradient here. It's higher, steeper, but it flattens, it reduces as you increase or as you go up here, which means we are decreasing the acceleration. We are still accelerating, but we are now accelerating with low numbers, not very high numbers like what was happening here. Maybe if we are to calculate the acceleration here, maybe we'll get 5 meters per second squared. That's our acceleration, the rate of increasing speed. We are increasing our speed 5 meters every second, 5 meters every second, as an example here. Here it's not very steep. We are saying we are increasing our speed with a low number, maybe 2 or 3 meters per second squared. We are still accelerating, but we are accelerating with a low number or low figure. The gradient is lower. Still the same like what we've done on the previous lesson or the previous slide there, where we're calculating the gradient using a tangent. You will be required to draw again a tangent at a particular point on the curve there, and you calculate your gradient using the triangle method, where you find your change in y over your change in x. Same thing with this one. Calculate your gradient by using the triangle method, change in y over change in x. And you get your gradient, which you are saying this gradient represents the acceleration. Notice that the gradient of the graph becomes less steep. We've commented on that. It's decreasing as we go up or continue with the motion. The gradient of triangle 2 is smaller than the gradient of triangle A. If you calculate these gradients, you see that this one is higher, this one is low. So the gradient gets less and less positive as the motion continues. So at the end of the day, we can have this one turning into constant speed. If we are to continue this, you can have it turning into constant speed there, and it can even decrease, going to deceleration. It's possible. Then the speed is increasing with decreasing acceleration. Very interesting there. The speed is increasing with decreasing acceleration. That's what I've said. We started with a high acceleration, maybe 5 meters per second squared, but we are now going to 2 meters per second squared as an example here. We are still accelerating, but our rate of accelerating has decreased. We are using low numbers. At a time t1, the initial year, our acceleration was a1, which is very high. Then at a time t2, our acceleration was low. So there's a decrease in acceleration as you move across the motion there. So at the end of the day, we have acceleration a2 being less than a1, which we started with here. It means our object is decreasing acceleration, and it can even go on to become constant speed somewhere here. If you are to continue the constant speed, then it can even decrease and come to a halt or a stop. Constant deceleration can complete this. A very important thing is when you use your tangent is to note that I have to calculate my acceleration, my deceleration using points which are on the tangent. You pick 2 points which are on the tangent to calculate your gradient. And as a tip there, one of the points is this one which they've given you to draw your tangent at T1 or T2. It's already showing you that this point is on the tangent. So you can as well make use of it. That's a tip which you can take there. Use one of these, but if you are not sure of it, you can just pick any points which you are seeing which are on the tangent, not necessarily on the curve. There's a big mistake which people do there, where they pick the ones on the curve. You are using points which are on the tangent which you have drawn. And a tip is, one of them is this one which they've already given you either as your T1 or your T2. Take note of that. Right, at the end here, we've got a list of past papers, questions which you can use to revise on this lesson. We have the 42, 43, 41, those appearing there is the extended option. Then you have got the 31, 32, 33, those are the core options. You can as well do all these questions for practice, reflecting on the topic motion. Going back, few pointers as we wind our lesson. You are required to know the definitions of these. As we moved in the lesson, I think you have managed to define distance. You have managed to define displacement, and you have seen the relationship between these two is that distance is a scalar quantity. It does not have direction. It only has size and magnitude. Displacement is distance, but it states the direction of motion, so it's a vector quantity. We have also managed to define acceleration, which is the rate of change of velocity or rate of change of speed. And when we say rate of change, it means we are dividing with per unit time. You have to divide with time. You have also managed to define acceleration. So you have also highlighted the key formulas that we need to use for your topic motion, starting with average speed, total distance divided by the total time. We have also gone on to talk about motion. We are required to describe motion using key descriptive words like increasing, decreasing, constant, uniform, or steady, as shown on the graph here. Constant acceleration, constant velocity, constant speed, or instead of saying constant, someone can use uniform, someone can use steady. They are all correct there. Constant deceleration. Then we have also looked at the other key objective, calculating the distance covered, and we said it's area under the graph. And don't hesitate to write area under the graph as a formula in there, and you put now the formula of the shape. The shapes vary, can be a triangle, it can be a rectangle or a square, or even a trapezium. You can calculate this whole area by just using the area of a trapezium. Your half A plus B times your H. You can use area of a trapezium. We have also highlighted on non-uniform acceleration, where you are required to draw a tangent. You are required to draw a tangent, a line touching your curve at one particular point. Then you use that line to calculate your gradients. You are going to pick points which are on the line, points on the line. And the tip was, one of the points is already that time given, the T1, in line with a certain speed here, which you use your ruler to get that. Then you calculate your gradients. Thank you very much. That was our lesson on motion.